Hello, and welcome to this quick take video focusing on managing project sources within the Vivado Design Suite. This training focuses primarily on the logic design sources such as RTL, netlists, IP, and so forth. Managing constraints and simulation sources are covered in other videos. We'll start out by introducing the sources view to show you how you can view and manage your design sources, as well as how to configure them for vhdl libraries, compilation order, simulation sources, and so forth. We'll also walk through how to replace and update sources, as well as disable source files so you can do a little configuration management within your project. The process for adding sources to the project was covered in the Creating Different Types of Projects videos. We'll briefly touch on it here to show you how to add various types of sources to the project. We'll also cover using remote sources, read-only sources, as well as configuring and adding IP sources to the project. We'll then cover saving and archiving projects, as well as where the sources reside within the project directory structure. And we'll finish up by reviewing some of the project management tickle commands. So once the Vivado integrated design environment is launched with an active project, the sources are all displayed within the sources window. Notice the different expandable folders to differentiate the different types of sources. You've got design sources, constraints, and simulation sources. When displaying the hierarchy tab within the sources window, the design sources are displayed in their compilation order. Notice top, when I expand that, I can see all the sources underneath top, and I can expand it down to the lower level files. Notice the module names are displayed here on the left, with the actual Verilog or vhdl files displayed in the right in parentheses. Holding the cursor over any of the source files will display a tooltip with the source file path. Double-clicking on any of the source files will load that source file into the text editor for edit. And selecting any of the source files will display the source node properties in the Properties view. This view details the location of the file. Notice it's down inside the project directory in the sources area. The type and library of the source file, the size, and a brief history of when it was modified, copied to, and copied from. Is the source read-only? Is it a global include file? Is it enabled in the project? And then which process would you like this source file to be used for? Synthesis, implementation, or simulation? Notice several of these settings are settable within this window. Selecting the Libraries tab in the Sources window will display the sources grouped by library. Notice all the Verilog files that are associated with library work. If I scroll down, there's a subtle difference here as well. Notice these sources with a green dot next to them as opposed to a white dot. The white dot means that these are remote sources. They are referenced outside the project directory, and the green dot means that they're inside the project directory, as you can see from the tooltips here. When I scroll down to the vhdl files, you can see the various vhdl libraries. I've got bftlib here with several files underneath it, and worklib. You can set any of the library names by selecting the source or sources and using the set library command. When I select the Compile Order tab within the Sources window, the sources are displayed in the order they're going to get compiled during RTL elaboration and synthesis. If for some reason the design is not compiling due to the order of the files, you can manually adjust the files within the view. Notice I've got the move up, move down, move to top, and move to bottom commands here. And when I select one of them, it asks me if I'd like to turn manual compilation on, so that the compilation order is up to me to set and not done automatically. One of the other things I can do from any one of these window panels is to replace or update the file in the project. I can select the file and use the Replace File command and select a newer version of that file or a different file altogether. Each time a source file is modified or updated, the hierarchy gets recompiled. And I can see that new date reflected in the Source Node Properties window. I showed you a minute ago that some of the sources were external to the project, or what we call remote sources. You can copy remote sources into the project by selecting them and using the Copy into Project command, or you can copy them all into the project by using the Copy All Files into Project command. Notice you can also remove files from the project from this menu. Some of the other things you can do include disabling the file, meaning the file stays in the project, but it won't be considered for the compilation steps moving forward. This way you can actually have two versions of a file and enable one for one run and enable the other for another run to, again, experiment a little bit with configuration management within the project. If I've inadvertently added a source file to the project that was actually a simulation source file, I can move that into the simulation sources area with the move to simulation sources command. I can also set whether I want the logic hierarchy to be automatically updated or whether I want to do that manually. I can use the set as top command to differentiate the top module in the design. Typically, you would use that to define the top level of the design, just in case the automatic hierarchy rendering didn't find it. But you could use set as top to set a module as the top level so that you could do module level verification, synthesis, or implementation on an experimental basis. You can also define whether a source file is a global include file using the set global include command. We already covered the set library command to set vhdl library names. I can set file type. I can define the file type for any source file, just in case the automatic rendering didn't get it right. And you can see the available values here. You can use the set used in command to determine whether this source file gets used in synthesis, implementation, simulation, or any combination of them. To add additional sources to the project, you can use the add sources command. The add sources wizard provides me with different options depending on the types of sources I'm importing. I can import constraints, create new constraint files, or even new constraint sets. I can add additional logic design sources. The dialogues are fairly consistent for each type of source. I've got the ability to add files, and I can browse and select files individually. Notice the file type filter at the bottom of the dialog, indicating the file extensions that Vivado will recognize as sources. Notice I can set the library on either files or directories for vhdl libraries. And I can elect to copy the sources into the local project directory structure or reference them remotely. I can also scan and add RTL include files into the project automatically. And when I'm adding directories, I've got the option to either scan the directory only or all of its subdirectories as well. And remember, when you scan the directories, all of the files with the extensions that you saw in that file filter in the Add Files dialog that are in that directory or the subdirectories will be added to the project automatically. I can create new source files of any type, and it'll open up the text editor and allow me to start typing source or add templates from the RTL template library. And there are some buttons on the side to control the order in which the sources are added to the project or to remove them from the list of sources to be added to the project. I've got the ability to add simulation sources or create new simulation sets, and those sources will display in the simulation area of the sources window. I'm going to elect to add a DSP core from System Generator. And notice the dialog asks me to select the .mdl format or System Generator project file. Notice I've got the same ability to either copy the sources into the project, or in this case I'll elect to reference them remotely. The entire System Generator module is added to the project, and then the hierarchy is updated to reflect it. You can see my DSP module, the DDC filter here, and notice it's on the same level as the top hierarchy. This module is not yet instantiated into the design, so any files or any source files for that matter that aren't recognized by the compiler will show up on the same level of hierarchy in the sources view as the top level module. This is helpful to debug the compilation errors you might have or to identify any unused source files in your design. I'll now go ahead and add a Xilinx Platform Studio microprocessor core to the project. I can either add or create a Platform Studio subsystem. In this case, I'll elect to add one and select the module1.xmp file, which is the project file from Xilinx Platform Studio. And again, the entire project is added as a module, and the hierarchy is updated to reflect it. Notice it as well has not been instantiated into the design and is displayed at the same level as the top design here. If I wanted to edit this module, I simply double-click on it, and it will automatically launch Platform Studio with my module loaded. If I make any changes and update the module, the project status would then be shown out of date. Even if I elected to edit the module standalone and it was referenced remotely from the Vivado project, I would still be alerted that my module had been updated and my project is out of date. This integration works the same way for System Generator and DSP cores. And the last source type that I could add to the project is IP. This is existing IP in either .xco core generator format from ISE or in the .xci format from Vivado IP catalog. I can add existing IP that's created standalone, or I can create IP directly within the project by using the IP catalog. Here I can select from the large library of categorized IP. I can configure the IP through the interface directly built into Vivado. And it will create the instantiation in the sources window as you see here. And again, notice this has not been instantiated into the design. One important thing to note about the hierarchy tab in the sources window is that IP, either IP through the IP catalog or through System Generator or Platform Studio, will all appear as a single module instantiated in this view. If you want to see the sources that are underneath the IP, select the IP Sources tab in the Sources window. And notice here I can expand each IP and see the sources that are associated with it. If I select the IP module in this view, notice I can generate the IP, reset the IP, or recustomize the IP, all within the project. I also have access to the datasheet, the version information, and the product website for all of the different IP. Now let's show you how Vivado keeps track of design status. Notice since we've been doing so much source manipulation, the project is now showing synthesis out of date. I'm going to rerun synthesis to bring it up to date. Notice that after synthesis finishes, the project is showing synthesis complete. Now if I were to edit or touch any of my source files, the project should go out of date. So if I select a source file, and I'll just affect one of the comments, save the file, and notice it's now showing synthesis out of date. Under the More Information link, notice it tells me which files were updated. There's also an option to force up to date. Notice I only made a comment change and I know the logic in the file is still identical. So I'll elect to say force up to date. And when I do that, synthesis is back up to date. Okay, now let's look at another scenario. What happens if you open a project and some of the source files have gone missing? You're met with a critical warning which tells you it could not find the file. Then if you look in the hierarchy, you can see that the hierarchy is not compiled and there are a lot of the USB source files at the same level as the top. Notice that when I expand the top hierarchy, it shows me the modules that are missing. So this is very easy for me to understand which file I'm missing. Once I resolve the issue on disk, the project hierarchy would be recompiled and display correctly. And if you wanted to save a snapshot of any particular design configuration or source configuration, you can use the Save Project As command to save the entire project to a new name. And notice I've got the option to import all of the source files into the new project directory structure. Alternately, I could use the Archive project to create a zip file of all of the source files and optionally all the run results as you see here, all bundled up into one file. Now I'd like to review where the project source files end up on disk within the project directory structure. Notice here I'm in the project CPU project, and if I push down into that project directory, you can see the subdirectories there for the different types of project information. If I push down into the sources directory, there are directories for design sources and simulation sources. And under design sources, you see the imports, the sources I've imported, as well as the IP. You can see all the design source files that I've elected to import into the project. The remote sources would not show up here, obviously, because they're remote. And if I push down into the IP folder, notice you can see the IP that I elected to add as a part of the IP catalog. The DSP and microprocessor cores that I added were added as remote sources. And finally here, we've been performing a lot of project management commands. Let's have a look at the tickle that was involved. To do that, I'm going to open up the project journal file, which records all of the tickle operations in any Vivado session. Notice the update files command, which is one we use to replace a source file with a newer version. The add files command was used to add both the System Generator MDL project as well as the Platform Studio XMP project. We created the adder IP and we customized it to set the B width, as you recall. So you see the set property command there to do that. And then we generate the target, which generates the instantiation template and puts it into the hierarchy of the design. There are a lot more project-related tickle commands. For more information, you can look in the Vivado Tickle Command Reference Guide. So in summary, the Vivado Design Suite provides an environment to manage sources and to perform system-level integration. The integrated design environment will automatically compile the hierarchy of the sources and will alert you to any compilation errors. There's a very intuitive display to help you manage sources. The design status is maintained when changes to source files occur. There's an integrated IP configuration and instantiation environment. And you can launch System Generator or Xilinx Platform Studio right from the integrated design environment to manage those respective cores. For more information on managing sources, please refer to the Vivado User Guide, Vivado tutorials, and quick take videos. Thank you very much for your time.